remind you of the tire problem from the homework that we did before, right? Very similar. So we have 3% are defective, which means that 97% are not defective. Okay? You purchased 3 of them. So we're going to do 3 slots. Find the probability that none are defective, which means 0.97 times 0.97 times 0.97. Okay? You trying with me? 0.9126. And you weren't here last time, but we never put percentages. So FYI. Okay? That's fine. Now you know. All right? All of them are defective would be 0.03 times 0.03 times 0.03. And what's that one for you, Zachary?
This is going to 272. It gave it to me. It's statistic.
Oh. How many zeros are there?
4. It's 0.27
times 10 to the negative 5. It's 4 zeros. All right. The first and third are not defective, but the second one is. So we're going to do 3 slots. The first and third are not defective, but the second one is. You should agree with that. Okay? So, I don't know what that is. Tell me. 0282. That sounds right. Exactly one of them is defective. At least one of them is defective. Exactly one, we have to be careful. Because it could be the first one, it could be the second one, or it could be the third one. This is actually, go ahead. That's exactly right. You can do that. So, because the second one was defective here, do you understand what Charles is saying? So we have to kind of write it. Now, there's a shortcut to answering this question, just so you know. This is called a binomial situation, and we'll look at binomials, and this is actually a binomial too, but we don't know about that yet. So for now, we're going to treat it as what I like to call a slot diagram. So exactly one of those is defective. This is, if you look at number 3, I have the second one being defective. So that is 0.0282 plus, well, I could put that 0.03 in the first slot, right? And I'd still get the same answer, wouldn't I? 0.0282. And then I could put the 0.03 in the last slot, I'd still get 0.0282. So when I multiply 0.082 by 3, or add all those together, what do I get? 0.084. Is it 6? 0.0846? Oh, it's okay. Thank you. We realize I'm around 5, right? Sandy. Say that loud. How that makes sense? Okay. Do you understand what 0.0282 came?
No, I know where that came from.
Okay. You don't understand why I did it this time?
Yeah.
Okay. Because this is my defective one. And the order matters. The defective one could be the first one, could be the second one, or, notice keyword, or it could be the third one. So I'm going to take that probability, or, and add it 3 times. Because the defective one can shift around. Is that better? Okay. Now, how did we answer number 5? At least one is defective. 1 minus the probability that none are defective, right? So none defective. And what was that probability? 0.9. Well, 1 minus 0.3 was it? Oh, 0.3 is the third, right? Can I do it that way? Is that
No.
917? None are the 0.97 is the third. None are defective. All right, that looks better, right? And what did you get?
0.0873.
Perfect. Gotcha. All right. So this is basically what you did on the first page of the quiz, right? No big deal. All right. I want us to kind of look at a couple of other scenarios today before I give you guys your homework. But I don't think we're going to do anything new, so to speak, today. I was going to introduce conditional probability, but from looking at the quizzes, I think we probably not need to rush through this. By the way, sample space. A lot of you missed that on the quiz. Let me just take a step before we're going to do problems. Let me take a step back. When I talk about the the sample space of flipping a coin 3 times? What I mean is, well, I could have all tails. I could have all heads. I could have a tail and 2 heads. That tail could now be in the second spot. That tail could now be in the third spot. So I have all tails, and this is all of my 1 tails. Next question. As long as the sample space is what I wanted. I didn't want a probability of each occurring. That's fine. As long as you told me what the sample space was. This is the sample space. Okay, the sample space is a list of all the outcomes. Right, now we have 2, I'm just doing tails. Now we have 2 tails. The 2 tails could be the first, the 2 tails could be the last, or the 2 tails could be the first and the last. And then I think we're done. I think that's it.
What about it?
I think I have them all, right? Yeah. I think that's it. So that's your sample space. To find the probability that you get at least 2 heads, I'm just going to use my sample space to answer that question. At least 2, is it 2 heads or 2 tails? I forget which one. So 2 tails. So at least 2. At least 2, at least 2, at least 2. So 4 out of 8, a half. 1 half is the probability?
Yeah. This is like an all or nothing. I watched it.
That's all I wanted to do. Did you guys make it too hard, do you think? I looked up here, I was like, oh, I'm surprised to see your answers.
I did the last one. I was about to do the 1 minus, and then I just realized that I had it right there.
That's why I had you draw the sample space, because you have all the possible outcomes there, and you just want to know what you need. That's the only one you get.
I knew like by heart how to do
So you mean, I see what you're saying. You mean like, what if you missed one of the sample spaces, but the question part B was based on that? That's a good point. I'll look at that. And if for whatever reason I end up marking it wrong, bring it to my attention, because I think that should be kind of fair. Based on whatever sample space you create, you should be able to answer part B. I agree with that. You should be double checking. Yes. Okay. Can we move on now? I was concerned about that question. All right. So, this is nothing new, but we're going to formalize it today. Let's look at this. I'm telling you we want to use a Venn diagram. Okay? A Venn diagram is one of the strategies. Emerson, we're not sleeping. Just because I turn the lights down so you can see it doesn't mean I want you to put your hood up and I want you to sleep. Okay? Put your head up. So, we need to fill in a Venn diagram, and I want you to do it. Okay? Remember how last class we ended with the Venn diagram where we had to find, I forget what it was, pets and cats and dogs or something like that was the example? So now we're going to change it to preferences of ice cream, chocolate, vanilla, both, neither, whatever. And I've given you some numbers, and I want you to fill in the Venn diagram. So let's start with that. I'm going to pause recording for a minute. I want you to fill in the Venn diagram that matches the situation. So what we have to do, since we know we have the word both, and I think I said this last time, anytime you see the word both, that should be a clue to use a Venn diagram. I'm not always going to tell you, use a Venn diagram here. Both is your key word. So because it says the word both, that's what I'm going to do. And I do have chocolate and vanilla, so I'll just go ahead and label them such. We always want to start with the both. We want to start on the inside, so 18 like both, so 18 goes in here. It does say 24 students like chocolate. Well, I do not put a 24 here. That is incorrect. Because 24 also includes the 18 that are already in the circle. So I need to subtract the 18 from the 24. When I do that, what's left? 6. So I have 6 people that only like chocolate, didn't like vanilla at all. Now I have 36 people that like vanilla, but again, I have to subtract off the 18, and what am I left with? 18. Good. Now, I also tell you that 50 people took the survey, which means that maybe they all add up to 50. Do they No. What do they add up to? 42. So I have 8 that didn't like any of the ice cream choices. Maybe they're a, cookie dough ice cream person or something. Or maybe they just don't like ice cream altogether. Huh? Cookies and cream is my favorite too. Although you know what I like? I like peanut butter and chocolate, but because my kids are allergic to peanut butter, like I have to like hide it and eat it. I feel like a bad person in my car. I'm like, my kids can't be near me. Like wash my shower and whatever. Anyway, all right. But I do like that. By the way, like positive warning, you don't want to do this, but thank you for listening. So let's go ahead and answer the question. How many people like chocolate? It really should say likes only chocolate, right? Let's add that word only. How many people like only chocolate? 6. Okay, good. How many people don't like vanilla?
44.
I'm getting all kinds of crazy questions. 44 is incorrect. Hang on. Doesn't like vanilla is going to be how many? 14. Now, I could just subtract the 36 from 50. Or I could also, doesn't like vanilla are these two parts of the Venn diagram, right? The 6 and the 8. Because they're outside of the vanilla circle. All right, 14. Like what? I'm not asking for probability, I'm asking for numbers. I'm going to say, oh, there we go. Hang on. Sandy's right. So, and that's a good point. Sometimes I'll ask you for numbers, and sometimes I'll ask you for probabilities. And either one works here, but he's exactly right. Find the probability that. So in each of these numbers, what will I divide by? 50. So 6 divided by 50 is 0.12. 0.28. Oh, anyway, like chocolate or vanilla, what would I do in my Venn diagram? What am I going to add? Once it's in the Venn diagram, I simply am going to add, or it's everything inside.
42.
42 out of the probability out of 50. And it's 0.84, that's not right. So that's going to be 42 out of 50. 0.84, you said, John? Okay. Like neither chocolate nor vanilla. I'm sorry, Isaiah.
Wait, for letter C, why would you add control if it's like chocolate or vanilla?
We've already done the subtracting.
Okay, yeah, sure.
Right? That's a good point. That's really why you do the subtracting for the Venn diagram anyway, because that's what the formula tells us to do. The reason we subtract is because we don't want to count the middle twice. Because we've already done our subtracting, the orange is everything in the Venn diagram. Okay? That's why Venn diagram is kind of helpful. All right. Are you two stretcher? Yeah. Okay, 2. Are you being all grammar?
I don't know.
I'm a math teacher. Sorry. Yes, you're probably right. I'm sorry. I don't know. Okay, let's keep going. Like neither chocolate nor vanilla would be 8 out of 50.
16. 16.
Okay. And then like chocolate and vanilla,
18 out of 50. 0.36.
All right, very good. All right. So again, organizing our information in a Venn diagram is just a way to really organize our process, organize our information. Here's another one, but this time I'm giving you the probabilities. A little bit different. Okay? So let's look at this particular situation. I always wanted to be a lawyer. And now I'm here. Probably wrong. Here's great, but yeah. Yeah, I actually went with like take your daughter to work day. I was went to like a American law firm in high school. I was going to be a corporate lawyer for sure. What happened? Chemistry. No, I actually changed. It was a pediatric orthopedic surgeon. I'm recording this. I get it.
You forgot
That's all right.
a in between make and partner.
Make a partner is actually the way it's supposed to do that. You don't make a partner. You just make partner. That's what it's called.
It's like a promotion.
Yeah. Like a partner is like a title. So like you make partner in a firm. Kind of like making a partner. Let's be partners. Yay, we're partners. Okay, that's not what it is. The partner's like a level. Okay. But thank you for trying to read the grammar, please. I appreciate it. I need it. Oh my God. All right, Venn diagram. Draw it. Let's see what happens. Okay, let's try. We're not gonna get it quiet. All right, talk loud because the microphone's back by my desk.
Okay, find the probability that Ted or Suzanne make partners.
It's Susan. That's right.
Susan. Sorry.
That's all right. So where'd you start?
What?
In the Venn diagram, where'd you start?
I first Venn diagram overlapping because that's what you're supposed to do. I put 0.4 in the middle. That's what it says. They both make partners.
Right.
You have to subtract the probability of 0.6 Suzanne. Why can't I say Suzanne? Like Suzanne.
That's all right.
You subtract 0.4 from 0.6. So that Susan will have 0.2 probability. And you subtract 0.4 from 0.5, so that Ted will have 0.1. And then there's a leftover 0.3 that neither of them can make partners.
Very good. All right. So, excellent. Thank you so much. All right. So, the first probability has, find the probability that Ted or Susan make partner. What am I going to do to answer that question? Right, everything inside of the diagram, or what do you get? 0.7. All right, that's easy. This next question is called a conditional probability. And we're actually going to wait until the question first. Because I added all of these up and subtracted from 1. Because everything inside the Venn diagram should actually be 1. Because that's what the total of the probabilities are. Is that okay? Where the point came from? Stuff? Yes, no? Okay. 6, 7, 0.3. All right, anyway, what I was going to say is this right here, the given that situation here is what's called a conditional probability. Well, find the probability that Ted makes partner. Just Ted making partner is going to be 0.5. Would you agree? Yeah. Given that Susan already has made partner, well, that's a different situation. So we're going to look at that next class. It's called a conditional probability. All right? I do have one more for us to do, and then that'll be it for today. Okay? So let's look at this one. The probability that you go and stack books for Miss Kim is 0.7.
Shots.
You get an A in math is 0.7. The probability maybe that you won't get to take the quiz on Monday is 0.8. Right. The probability to get an A in science is 0.8. An A in both. What's the key word? Both. And what does that mean we're going to be drawing? All right. Yes, sir. Oh, you already did one. Anybody else? Okay. So I agree with Devin's Venn diagram here. Science or math. We start in the middle. We subtract. We go forward. We could also use the formula. The Venn diagram is a way to organize, but let's do it using the formula as well, because it should work that way too. The probability that you get an A in science or math. Okay. Science or math. Let's think about in context. Guys, this is important. The formula in context, the addition rule, is the probability of science plus probability of math minus the probability of science and math. Right? Isn't that the formula? Look at your A and B. That's the first formula on that probability sheet, correct? So let's plug in the numbers. Probability of science is 0.8. The probability of math is 0.7. Minus the probability of both is 0.6. What do you get? 0.9. It's the same thing as what we got using the Venn diagram. The Venn diagram, you've already done the subtracting. It's a way to organize it, that's all. I don't care if you choose not to use the Venn diagram and you choose just to use the addition rule. That's fine. Sometimes, though, Venn diagram because you're not given all the information in the problem. So you have to figure out, like the problem we did last class with the cats and dogs, I don't think you were given everything in the problem. You had to kind of work backwards, if I remember correctly. Okay? So your homework is going to be chapter 15, only 1 through 8. Okay? That's all you have to do. So your homework is chapter 15, 1 through 8. I will tell you that there are some Venn diagram problems in there. Please draw them, okay? And then there are, I think, just some sample space questions too, as well. So